Okay, this is going to get you ready for quiz 9C, the retake. You have a balanced equation, and this one says if you react 1 mole of this stuff with 1 mole of this stuff, which of these is going to be the limiting reactant? So it doesn't matter which product we pick. Either one of them will give us the answer, but notice that it is referring to carbon dioxide later on in the problem. So I'm going to use that as my test product just because it saves me some time later on. So we're going to ask two questions. How many moles of CO2 are 1 mole of CS2? All right, got our balanced equation. So we're going to go from moles of CS2 to moles of CO2. And the ratio is 1 to 1. That means we're going to get 1 mole of CO2 from that stuff. All right. Fair enough. What do we get from the oxygen? How many moles of CO2 could we expect from our 1 mole of oxygen? And according to the equation, the ratio of oxygen to CO2 is 1 to 3. Well, would you look at that? It means that the oxygen is the limiting reactant because it only allows us to make 0.33 moles of CO2. Where the CS2 allows us to make 1 mole of CO2. So what we know is that O2 is the limiting reactant. That answers that question. Well, how many moles of each product are formed? We already did with CO2. We already know all we're going to get is 0.33 moles of CO2. So we know that part. Notice that we're going to find out how many moles of our other product, that's this guy, can we get from the same limiting reactant. How many moles of SO2 are the equivalent of 1 mole of O2? Moles of O2 to moles of SO2, and the equation is 2 to 3. So I'm going to say 1 times 2 divided by 3.66 moles of SO2. So you know exactly how many moles of CO2 and how many moles of SO2. All right, here's what we know. If only 0.25 moles of CO2 are produced, what is the percent yield? The formula for percent yield is a real simple one. It's equal to the actual yield divided by the theoretical yield, and we're going to multiply that by 100. All right, well, what's our theoretical yield? What's the theoretical maximum amount of CO2 that we could get from this reaction? We said that the C2S2 allows us to make 1 mole of CO2, but that the oxygen only allows us to make 0.33 moles. This is all the problem's going to allow us to make. So this is going to be our theoretical yield. We're going to plug that right in here. And what we know is that we're only going to get 0.25 actually produced. So what we're going to say is this. We're only going to actually get 0.25 moles. We know we could theoretically get 0.3 moles because that's all our limiting reactant will allow. So let's plug these into this equation and say, all right, if we know the actual yield is 0.25 moles, the theoretical yield is 0.33 moles, and we'll multiply that by 100. So we're going to say 0.25 divided by 0.33 times 100, and that is 75.75757575. Let's just call that 76% yield is all we're going to get. Okay, that took me 5 minutes. That didn't take long. Let's do this last one. It says if 16.2 grams of magnesium react with 12 grams of H2O, which of these reactants is limiting? Well, we're going to pick one of these two products. And notice that it mentions magnesium hydroxide later on. So I'm going to use that as my test. First thing that we're going to do is ask how many, and I'm just going to go to moles first because all I need to do is find which one is limiting. How many moles of magnesium hydroxide are the equivalent of 16.2 grams of magnesium? So that's going to be the first step. We're going to go from grams of magnesium to moles of magnesium. And we know that according to the periodic table, 1 mole of magnesium is 24 grams. Now we can go from moles of magnesium to moles of magnesium hydroxide. According to the ratio, it's 1 to 1. So our calculator is going to tell us 16.2 divided by 24 times 1 divided by 1 is 0.675 moles of magnesium hydroxide. That's what the magnesium is going to allow us to make. You react 16.2 grams of magnesium, you get 0.675 magnesium hydroxide. Let's do the same thing with the water. How many moles of magnesium hydroxide could we expect to get from our 12 grams of water? So, how many moles of magnesium hydroxide could I expect from 12 grams of water? We're going to go from grams of water to moles, and we know the molar mass of water is 18 grams. Now we can go from moles of water to moles of magnesium hydroxide, and we've got a balanced equation that is telling us that the ratio of water to magnesium hydroxide is 1 to 2. That's the 1, that's the 2. 12 divided by 18 times 1 divided by 2. Sorry, I did that wrong. 12 divided by 18 times 1 divided by 2. Would you look at that? 0.33 moles. Well, the magnesium allowed us to make 0.675. Apparently, this 12 grams of water is only going to allow us to make 0.33 moles of magnesium hydroxide. That means that the water is the limiting reactant. All right, 0.33 moles is all we're going to get. What mass of this is it? Well, check this out, ladies and gentlemen. This is all the magnesium hydroxide we're going to get, 0.33 moles. It's asking what mass is this? So, how many grams of magnesium hydroxide are the equivalent of 0.33 moles of magnesium hydroxide? We're going to go from moles of magnesium hydroxide to grams of magnesium hydroxide. All right, here's your chance. If you still are wondering how I'm getting these numbers, let me find a periodic table and I'll take you there. So we have 3 elements in magnesium hydroxide. We have magnesium, and that tells us that magnesium's got a molar mass of 24.3. I'm just going to round that to 24. So I'm going to write that right here under my magnesium, that the magnesium has a mass of 24 grams. Go back to our periodic table and it tells us that oxygen has a mass of 16, 15.9994. I'm just going to round that to 16. I'm going to put that right there. And finally, the hydrogen on our periodic table has a mass of 1.007. We're just going to call that 1, ladies and gentlemen. Okay? So, here's what we know. And that's where I got those from. So magnesium's got a mass of 24 grams. You've got 2 hydroxides with 1 oxygen and 1 hydrogen. We know the oxygen is 16. We know the hydrogen is 1. That means the hydroxide is going to be 17, and there are 2 of them. So 2 times 17 is 34. You're going to add the 24 from the magnesium to the 34 from the hydroxide. Let me put those back. Magnesium, hydroxide, and you get 58. And that's where I got that from. So I'm going to say 0.33 times 58. What's the maximum amount of magnesium hydroxide I can get? 19.14 grams of magnesium hydroxide. You're almost done. All right, right there. This is the theoretical amount of magnesium hydroxide you can get. It says, theoretically, it says it right there. That means that our theoretical yield is 19.14 grams. But it says the question only runs at 75%. So we're going to flip our equation for percent yield around. If we know that percent yield is equal to the actual yield divided by the theoretical yield times 100, we're going to flip this around by taking theoretical and multiplying both sides by theoretical, dividing both sides by 100. So now actual yield is going to be equal to theoretical yield times percent, and we're going to divide that by 100. You don't have to memorize that, just write it down somewhere. Well, what do we know about this problem? We know that it runs at 75%, and we're only theoretically going to get 19.4 grams. So what mass are we thinking we're actually going to get? Our theoretical yield is 19.14 grams. We're only getting 75% of that, so times 100. Here is my answer, 19.14 times 75. Divided by 100 is 14.36 grams. And that's all you do. Good luck on the quiz tomorrow.